Hello everyone, welcome back to my channel. This is the place where you learn new skill every time you visit. So keep updating yourself by subscribing to the channel.
Today we are starting a new series, the problem solving series, because you people have been sending me a lot of questions, a lot of problems which you face in coding. And the first video is on number problem.
So the first problem which we are taking on is we have to write a code in Java or in any other language, right now in Java, which will input a number and print the sum of the square of the first and the last digit. Alright. So here we'll break the number into different digits first using the method which we have discussed in the previous video. Now the thing is, how will you recognize that first digit and the last digit? Since you are going in a loop and you're continuously breaking the numbers number into digits, which you know that starts from the end. Suppose the number is like 423, something like 423. Then first this will come out, then this will come out, then this will come out. Now here you need to sum the first. This is the last of the number and the first, which will be the first in the process. So here I'm in the BlueJ and I have opened the file PS1 Q1, that is the problem solving question one. Alright, if you want these compiled code from me, I'll mail back to you, just write to me. So we'll create the same class name PS1 Q1, right? Class name can be anything, as you know. And here we have to create a main function, and then we'll start coding inside that. So here we go. All right. What we are going to do over here is we have to first connect our input device. Using the scanner class. Okay. And for that, I need to import these are the things which you have to do every time. Java.util.start. All right. So now I'll take a variable into which I'll take the input from user, the number. Then I need a variable in which I'll store a digit. Then I need a variable in which I'm going to sum it up. And I'll store a 0. Okay. Now the thing is, how will you come to know that that's the first digit and the last digit? Because the process is going to happen in a loop. In a loop, and keep on breaking the digit, you have to put some conditions so that you can make out that this is the last digit and this is the first digit. All right. So I'll just explain you here. Try to explain you here. Suppose the number is 4579. First time when the loop starts, it's going to pull out this, which is our last digit. Okay. So I will take a counter. Simultaneously, I will start doing also. So I'll take one counter variable, which will tell me the position, how many times the repetition has happened. So what I need is this number which is going to come out or break out in the first instance or in the first iteration of the loop. All right. So then I'll run my normal loop, the digit breaking loop, while number is more than equals to 1. You all know this we discussed already in the previous video. Digit equals to number modulus 10 and number equals to number by 10. All right. Now you have to put a condition over here stating, okay, I need to get the number also from the user. I'm sorry, because input has to be taken. Or either you can store the value, that's also fine. But let's take the input. Enter a number. So number equals to, after that, because the declaration has to have before that. So after declaration, I can take it on. Anno equals to sc dot next end. So here I got the number now, and I started the loop as we do for digit breaking, as you all know. And now I'll put that since for the first instance when the loop is entered, the value of count is going to be 1. So what I can say is if count equals to 1, then s equals to s plus dig. All right. So whenever the counter is 1, it's going to sum that digit into s. And then it will continue the loop process. All right. So when it comes out of the loop here, in this particular case example, which I've shown over here with a marker, when it comes out of the loop means when it comes out after taking this out, after taking this out, after taking this out, after coming out of the loop, the value of s would be, initially it was 0, so 0 plus 9 is going to be 9. All right, so I have already summed the last digit. Now, what's my task is to sum the current digit. So when it comes out of the loop, at this time when it's coming out of the loop, the last value of dig, okay, is holding 4 only, isn't that? Is holding 4 only. If you want to check it out, let me show you. What I'll do is I'll print every digit here, okay? I'll print every digit here. So you'll come to know what is the current digit. So digit is plus dig. Okay. I think let's compile it. So it's going to print every digit which we are compiling. Let me go to the compiler and run this. So here's the question. Here it goes. Here it runs. Asks me a number. I give a number 65431. And it shows me that the digit, the value of the digit is 13456. Now you notice that, see, in the last, the last value of the digit is 6. So that means when it comes out of the loop after doing the process, after ending the process, after ending the loop, because loop is ending here, this loop is ending up here, the last value of digit is going to be 6. That also we can confirm by, I'll show you how. If I print this digit value outside the loop, okay, so every digit is not going to be printed. What is going to be printed? The last one, the last value of digit. And I'll see that the last value of digit which is getting printed would be the first digit. Okay, let me show you. So here I go. I compile and quickly I move to the main screen and run it. So here it goes. Yeah. So I give the number 76542. You see the last digit is 7, means the last digit of the process is 7, which happens to be the first. So what I need to do, I have already summed the 2 into the sum. I just need to put this, sum this digit into my sum variable, and I'm done with the problem. But the question said, I believe square of the right. So nothing, I'll just square the digits here and sum it up. And outside the loop, I'll also sum up the last digit, which is currently stored in the variable digit. And then I'll print the sum. So this is your answer. Sum of square of first and last digit is x. Let's compile it again and see the output. So here it goes. So you see the square of 6636 and 224. Sum of squares of first and last digit. 2 square is 4, and I think it has exceeded the, let me check it out. It has exceeded the integer limit. What do I mean by exceeded the integer limit? That means if count equals to 1, okay, what I need to do, I need to increase the counter. See what's happening here. I'm not increasing value of count. So the count value remains 1. So when count value remains 1, it's going to sum up every digit. Okay, so I need to increase the value of count by 1 so that that sum hash, which is done in the first iteration of the loop, should be there. Other digit, I don't want to sum it up. Now it will work properly. Compile. There it goes. And here is the output. See, 36 plus 9 is 45. You see that? So this sorts out your first question. Okay. Now we'll move on to the next one. So here's the next problem, guys, and which says that write a program to classify abundant, deficient, and perfect numbers. So one by one, we are going to do this. First, we'll do the abundant number. In number theory, an abundant number is a number for which the sum of its proper divisor is greater than the number itself. All right. So the first few abundant numbers is given here. I'll explain you what do they mean by the question. Suppose the number given by the user is 12. All right. Now the divisor, the proper or the perfect divisor of 12, right, are 1, because 1 divides 12, 2, 3, and 4, and 6, excluding the number itself. Okay. Now if I add all of them, the sum is 16. And since 16 is more than 12, so it's an abundant number. All right, abundant, going above the value of that number. So this is where we have to code it, right? Since here in this question they ask you to write a program to classify a number between 1 to 10,000. So that means we are asked the user to give a number between this range. So here I am in BlueJ and I have kept the format ready because in most of the questions in number problem digit breaking we'll have to do all these things again. So I have already pasted it. So this is the second question of the problem solving series 1. Now enter a number. Now as I told you that we need to check whether the number is between 1 and 10,000. So what we can say, if, you can put a if number is more than or equals to 1 and number is less than or equals to 10,000, then only you will start the process. All right, then this whole thing will go inside the if. Else you have to say invalid number. So I'll paste and I'll change the message. Invalid number. Okay, guys, and I'll close the else also here. Okay, now the question was you have to find the sum of the divisors. All right, sum of the divisors. Now we are not dealing with the digits. We have to find a divisor. Divisor means a number which divides another number. When we say which divides another number, that means when the remainder happens to be 0. When you divide a number with another and the remainder happens to be 0, that is a divisor. So what we'll do, instead of dig over here, I'll take another variable called remainder. Okay. So what I'll do, I'll calculate the remainder here inside the loop. Or I can directly check it up with the if, but let me do it this way. That's the easier way for you to understand. So R equals to number modulus. Okay. Now one more thing. Suppose you are checking for 12. Let's take the example which was given in the question 12. So the first you will divide the 12 with 1, right? Then you with 2, then with 3, then with 4, and keep on dividing so on till 11, not reaching the 12. All right. Now since it's this question, you know that you are starting with 1 every time and you are going one number less than the number itself. All right. So what you can do over here is you can skip the while loop and you can have a for loop because you know from where to start till where to go. So you can also do it with while loop. That's no problem. But for loop here is going to be very easy for you. So let's move on to the for loop. I equals 1, I less than equals to the number, less than number not equals to, I equals to I plus 1, and now what we have to do over here, you need to check, you have to find remainder as I was doing earlier. So R equals to number modulus 10, I'm sorry, not modulus 10, modulus I, because I is the value which is going from 1 till that 1 less than that number. So I have found the remainder, REM I have taken for the remainder, So I have to use the same variable. Now, if this remainder happens to be 0, that means the particular value of I, whether it is 1, 2, 3, 4, or any other thing, has divided number. So that's going to be a factor. Now, when it's going to be a factor, what I need to do, I need to sum it. All right. So S equals to S plus the number which divided it, which is I. Okay. For example, over here, look at this markers. Suppose 1, first value of I is going to be 1. 1 is divided 12. Yes, because the remainder is 0. So I'm going to add the 1 to the S. Now I will move on to 2 because the loop is proceeding. So 2 will again divide, the remainder happens to be 0. It will again 2, add 2. Similar 3 will again divide. So I'll add 3 also. 4 will again divide, I'll add 4 also. Now when we come to 5, 5 will not divide. Okay, so I'm not going to add 5. So that's why this condition, if remainder happens to be 0, because in the case of 5, the remainder will not happen to be 0. All right, remainder will be 1 when divide. I think 2, 5, 2, 10. Yeah, 2 remainder is going to be 2 with 5. So this condition won't be satisfied, so that sum won't take place. All right, I think you understand it. Now I summed it, and now out of the loop, when I come out of the loop, so I shall have the sum with me, which includes all the divisor excluding number. Now, if this sum happens to be more than the number, okay, then what it is? It's a abundant number. That's what we have to say. So I'm going to print it out. I just copied the message and I'll print it out. Let's do it. The number NO is abundant number. All right. And if closes there, and let me just align it properly so that it's easier for you to understand. Yeah. So here we got the number. We check whether the number is in the range. Then only I'm going to proceed. So in that particular loop, there I check the number. I have running a loop from 1 till 1 less than the number because you don't have to include the number. Then you are finding the remainder by dividing the number with all values of I, which start from 1 and 1 goes till 1 less than the number as per the question. Then you're checking if remainder happens to be 0. That means it's a divisor. You're summing it up, summing the I into the S. Right? And once the loop completes, you say if S is more than number, it's an abundant number. All right? And else, if that condition, this else is for this. If this condition, if the number happens to be above 10,000 or less than 1, then it will say invalid number. Let me compile and see how it works. So here I go. Compiles. Let me move on to the main screen. Here it is. And here it goes. I'll get 12. This is a abundant number that we already know. So before putting on some other number for checking, we also have to check whether it's a deficient number or a perfect number, right? So we have already checked this condition that if the number happens to be, the sum happens to be more than the number, then it's an abundant number. Now, if it is not, so there can be two cases. Either it can be equal to the number. In that case, it will be a perfect number. So I just put a statement here. If S, the sum equals to number, it is a perfect number. And if it does not happens to be equal to the number, if the sum does not happen to be equal to the number, then and in that case, if the sum happens to be less than number, anyway, you need not to check that condition because here it will only come when all the above conditions are not met. All right, and that is the only case which when it comes here, when the sum is going to be less than the number. But anyways, if you have any problem in understanding that way, so you can put a condition, or in all ways it works, whether you do put the condition or it doesn't, you don't put the condition. So here I'm doing if the sum happens to be less than the number, it's a deficient number. So let's copy this message here, and I'll say number is deficient number. Deficient number. All right, let's check it. So I'll compile it here. Compiles with no syntax error. I will go back to the interface, run it, and here it goes. So I'll give say 15. It's a deficient number. Okay, where the sum is less than the 15 because the factors of 15 are going to be 1, 3, 5. All right, so 1, 3, 5, the sum is 8, 9. So which is less than the number itself. For a perfect number, let me check one more number, like 144. Is it an abundant number? All right, so this way.
If you give 28, so it will say it's a perfect number. Okay. So that's it with this part of the video. Since it's becoming longer, so I'm breaking it into two parts. Next few problems in the next part. Thank you for watching. Bye bye. Take care.
If you are new to the channel, please subscribe it. Also press the bell notification so that you get notification as soon as I release a new video. Share and like the video.